so that we, yes. So let's now get to the business of the day. So guys, I think from grade 9 and grade 10, you guys are familiar with laws of exponents, right? You guys are familiar. So can you guys see my screen?
Yeah.
Hmm?
Yes.
You can see.
Yes, sir.
Let me check. Right? Can you see what I am writing? So let me say draw here so that I can check. Can you guys see this? What I wrote there? Can you guys see that?
Yes. Yes.
Okay. So let me continue. Select the pen and broaden the screen itself. Yeah, I think this should be fine. So guys, we are going to start by stating the exponential rules, right? I think that I can say the first one that we are going to start with is this one of when you are multiplying powers of the same base, right? So let's say you have, okay, first and foremost, let me try to introduce you first to what can be expressed, a number expressed as an exponent, right? So with normal terminology, let me say a raised to b. So this a right here can be regarded as our base, and that b there is regarded as an exponent, right? So that's this number right here, this a, we regard it as a base, and that b, we can regard it as an exponent, right? So this is a base, and that is an exponent. So, and formally, all of it, a to the exponent of b, can be expressed as powers of a, right? So all of it can be referred to as a power, but you can just say a to the exponent of a what? Of b, right? So that's the terminology. This is a base, that is an exponent, right? So now let's continue with our rules, or rather laws. So now let's commence with the first one, right? Uh, you do know that whenever we multiply powers of the same base, like a to the exponent of b times a to the exponent of c, it's just going to be equal to what? To, we keep the base and then we add the what? The base. It's gonna be b plus c, right? So that's the first one. And then, so now we just spoke of multiplying. What about when we divide? So let's get to the concept of division, right? So now, let's say we have a to the exponent of b divided by a to the exponent of c. So now, you know that division is the opposite of what? Multiplication. So now, instead of adding, you are just gonna what? Subtract. So it's going to be a to the exponent of b minus what? C, right? Are we all on the same page? Guys, please mute your mics if in case there's any noise in the background. Please mute your mics. Mute your mic. Mute yourself. Please mute yourselves. Just unmute yourself whenever you have a question, please. So let's let's continue. So with regards to now the third one, I do not know what Zoom is saying. Since I have load shedding, I'm having internet connection problems, but let's not mind that. So we just spoke of multiplying and dividing. So now what of the issue of when we what? When we, let's say now I have let's say I'm just going to introduce a trick now. Let's say I have some, let's say, uh, a base raised to a negative exponent, let's say b. So this is just gonna be 1 over a to the exponent of what? B. So this is a law, right? So that's how you can change a base which has a negative exponent to something which has a positive exponent, right? So that is how you can do it. And this is still the same as 1 over a to the exponent of what? All to the exponent of what? Of b. Are you guys okay? Okay, let's continue. So now we've destroyed this negative exponent and now we've made it to be what? Positive. Yes. So now, uh, let's go to number 4, right? What if now we are dividing, let's say I have a divided by b all to the exponent of negative c, right? And I want this c to be positive. What can I do? All I can just do is just simply swap A and B. So whatever was at the top, I can take it to the bottom. And whatever was at the bottom, I can take it to the what? To the top. So I'm swapping my numerator with my denominator. So that's where B is going to go to the top. And then I'm going to divide now with what? With A. So now I'm going to be remaining with the what? A positive exponent. So now this negative sign gets destroyed or disappears because I have now swapped the numerator and the denominator. So that's just one of the fundamental laws. Yeah. And then let's speak of when you add bases, right? Let's say you are adding, um, I just want to show you guys something. Let's say I have a to the exponent of b plus a to the exponent of c. Guys, this thing is not the same as a to the exponent of b plus c. Why? Because look here. Here you are what? You are adding. But so for you to get a to the exponent of b plus c, you must have had a multiplication what? Sign. So these two things are not the same. They are not the same. Those two things are not the same. So now, let's now continue. Okay. So now I just want to move to something that you guys know, right? Something that you guys know. Let me just call it number 6. This thing that you guys know, it's just that concept of like any number raised to the exponent of 0 is always what? Equal to 1. So I can raise any variable, any base to the exponent of 0 and I'll always get what? 1. I will always get 1. Do you guys understand that? Any questions so far? Are you guys okay?
Yes. How do you
How do I?
solve number 5?
Oh, when I add, when I'm simply adding, how do I solve it?
Yes, sir.
Which number 5? Or this one? That one?
Yes,
That's,
sir.
yeah? I can't hear you, sir.
Yes, that one, sir.
That one. Okay. When you are simply adding them, just
Yes.
know that these two things are not the same. But what you can look out for is whether or not, can you take out a highest common factor between the two. But that you will see when we are doing examples. For now, I just wanted to highlight the issue that most learners normally make. When you see the same bases that are being added with different exponents, do not add the exponents and keep the base. You do not do that. You do not do that. Are we on the same page? So you will
Yes, sir.
see
Thank you.
what happens. You will see as we get to examples, you will see how we deal with these kind of scenarios whereby we are just adding the same bases with different exponents. Are you okay with that?
Yes, sir. Thank you.
Okay. So now, can we head to now? We can now, do you allow me to continue with examples? So these are just the fundamental laws, and there's not many textbooks have a lot, but I always feel like these ones are the most necessary ones because you guys do know, you do come from grade 9 and grade 10, and you do have a bit of background on the basic laws of exponents. But now I believe the more we do examples, the more you can become sharp at it. So I'm going to pick several problems from here, and then you guys will see how we can continue. So do you guys allow me to continue? My fellow, my dear learners, I'm going to be applying these laws that I just spoke about.
Yes, sir.
Yeah.
Yes, sir. Yes, sir.
So let me start with letter A, right? I'm going to start with letter A. So letter A, they are saying they have A times B squared times C. Please mute yourself. Please mute yourself. Please mute guys. Please mute yourselves. Let me continue. So we have A multiplying B squared multiplying C cubed. All of these are different bases. They are all multiplying each other, so we cannot add the exponents. But all of these variables which are multiplying each other are all raised to the exponent of what? 0. So I remember telling you a law that said any variable raised to the exponent of 0 is always what? 1. I remember telling you guys this law. Any variable or any number raised to the exponent of 0 is what? 1. So now, tell me, is this not a variable? These variables multiplying each other. It will all make up a single variable or number, right? And then we are raising it all to the exponent of what? 0. So therefore, all of this is just going to be equal to how much? 1. Do you guys understand?
Yes, sir.
Guys,
Yes, sir.
do you guys
Yes,
understand? We are
Yes.
raising all of this inside the brackets to the exponent of what? 0. So it's always going to give us what? 1. Is that okay? Guys? Hello?
Yes, sir.
Okay. So
Yes.
I've just
Yes,
applied
sir.
one of the laws, right? Fine. So let me teach you a new one before I continue. So let's go to number 7, right? So to number 7, I want to show you guys something like this. Let's say I have A times B inside the brackets, right? But I'm raising it all to the exponent of what? C, right? I have different bases, but all raised to the same exponent. But they have multiplication in between. So therefore, I'm going to have what? A to the exponent of what? C times B to the exponent of what? C. So whenever you have multiplication in between, you can give every variable inside the brackets the same exponent. You can give it the same exponent. So therefore, whenever we go in reverse, we can say, if in case you are multiplying different bases, but with the same exponents, you can take out the exponent and multiply the what? The bases. You guys understand that? So here I'm going forward. So when I'm going forward, I can just simply say, I have A times B, so all raised to the exponent of what? C. So this is going to give me A to the exponent of what? C multiplied by B to the exponent of what? C. So we give each variable the same exponent, right? And we still multiply. We keep that operation. We keep the operation, but we now give each different variable the same exponent. So now, if in case that is what we were able to do with multiplication, tell me, what if now I have, let's say number 8, I now have, now A divided by B all to the exponent of what? C. This will just tell me that these are different bases, right? The exponent is positive, so I can give each base the same exponent, but I still keep the division sign. So I'll have A to the exponent of C divided by B to the exponent of what? C. Because remember, we just came from what? Multiplication. And with multiplication, we had two different bases multiplying each other, all raised to the same exponent. So what did we do? We gave each base the same exponent, and we still kept the operation, which was multiplication, right? So now we managed to destroy these brackets by simply giving these bases the same exponent, right? So that is what we did. So now with division, we are still going to do the same. We have different bases, A and B. They are dividing each other. And now what will we do? We are going to give A the same exponent as what? As B. And we keep the division line. So it's going to be A to the exponent of C divided by B to the exponent of what? C. Are we all on the same page, guys? Hello? My dear learners?
Yes, sir.
Okay.
Yes.
So now that is still okay, right? That is okay. So I want to now show you guys, possibly, this was just a short way of doing this calculation. See this calculation that we just did of, this is just all a variable raised to 0. It's going to be equal to 1, right? So another person, possibly who likes doing things the long way, could have done this, right? We know that the question is saying A times B squared times C cubed all to the exponent of what? 0. So what are we going to have? We are multiplying all of these numbers, right? So we are going to give each of these numbers the same. We are just going to give them the what? The same exponent, right? So we are going to have A to the exponent of what? 0 multiplied by what? By B squared to the exponent of what? 0 times C cubed all to the exponent of what? 0, right? And what is A to the exponent of 0? it's going to be equal to how much? Equal to how much? What is a to the exponent of 0, my dear learners?
1.
It's going to be equal to
1.
1, right?
1.
Multiply by b squared to the exponent of what? 0. It's just a variable. It's going to be equal to how much? Also, it's going to be equal to 1, right? B cubed is also still a variable. We are taking it to exponent of what? 0. So it's going to be equal to how much? 1. So we are going to have 1 times 1 times 1. This is just simply equal to what? To 1.
1.
You see, guys? So there's different ways of killing a cat, but always take the shortest one. So here we already saw that all of these things are multiplying each other, but even though that they are multiplying each other, we are taking them to the same exponent. So they are just going to give us what? They are all taken to the same exponent of 0. So they are going to give us what? A value of 1. Do we understand each other?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So now let me go to number 9. Right? Number 9, it's going to be something that you guys are a bit familiar with. Right? Let's say I have a to the exponent of b. Right? This a to the exponent of b, I'm raising it all to the exponent of what? C. So now a law says I'm going to simply go to the furthest exponent. So I'm still going to keep my base of a, and then my new exponent is now going to be b multiplied by, let me erase there, let me erase. I want to write properly so that you can see. So it's going to be a to the exponent of b multiplied by c. So this is now going to be the new expression. This is now going to be the new expression. So that means, so this is just a law. I have a certain base raised to a certain exponent, right? A to the exponent of b. But all of this is raised to the exponent of what? C. So therefore, I'm going to keep the base, but now I'm going to multiply the what? The exponents. I'm going to multiply the what? The exponents. Do you guys see this?
Yes, sir.
Guys,
Yes, sir.
Yes, sir.
it's a law. We accept it
Yes,
as
sir.
it is, right? We accept it as it is. So let's now go to number 10, right? For number 10, it's just going to be the same. I'm going to say a to the exponent of b divided by, let's say, b. Let me not say b. Let me erase there. I want to say, let me say c to the exponent of what? D. All raised to the exponent of what? Of f. So this thing is just going to simply be equal to what? I'm dividing, right? But this is raised to the exponent of b. So what am I going to have? I'm going to have a to the exponent of b, right? All raised to the exponent of what? Of f. All divided by c to exponent of d. All raised to the exponent of what? F. And this just comes from this number 10. It comes from which law? Look, it's just coming from the law that we had in number 8, whereby we had a, and then we gave it the exponent of what? C, right? So even here, we still have a to the exponent of b, but we are taking it to the exponent of what? F. We still have c to the exponent of d. We are taking it to the exponent of what? F, right? You guys see that? Guys,
Yes, sir.
you understand that?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay. So now let's take it further and now apply law number 9. So this is whereby we are going to say a, we have a to the exponent of b, but raised to the exponent of f. So this is going to be a to the exponent of what? B times what? F, all over c to the exponent of d is all raised to the exponent of what? F. So this is going to be c to the exponent of d times f. This all comes from law number what? 9, whereby we had a number raised to a certain exponent, all raised to a certain other exponent. So even here we have a to the exponent of b, all raised to the exponent of what? F. So we keep the base, but we multiply the what? The exponent. So even here with c, we have c to the exponent of d, but now all raised to the exponent of what? F. So we are going to keep the base, which is c, and multiply the exponents d and what? F. You guys understand that?
Yes, sir.
Guys?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Okay. So now, that is now the case. We are running out of time. So in 10 minutes, I'm going to send you guys another link, right? I'm going to send you guys another link. So because our class is ending at 22:09, I'm going to send you guys another link. So for now, let's just continue. So I think now we are done with letter A. We can move to letter what? B. You guys allow me to go to letter B?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Yes,
So with
sir.
letter B,
Yes, sir.
the question that I'm given says it's 1 over xy to the exponent of 3, right? Do you understand that? So the first thing that I'm going to check is my exponent negative. It's not. So I
No.
do not have to swap the numerator and the denominator. Fine. But now I have 1 and I have x times y at the bottom. I have x times y, right? So what I'm going to do, according to law number, this law of number 8, I'm just going to take what? I'm going to take whatever is at the top and give it the exponent of that exponent which is outside the bracket. And I'm going to take whatever is on the denominator, give it the exponent that is at the top. So what I'm going to do now, I'm going to say this is just equal to 1 to the exponent of what? 3. All over what is at the bottom? X times y. All to the exponent of what? 3. And what do we know? 1 to the exponent of 3 is just 1. Do we understand that? Guys?
Yes, sir. Yes, sir.
You can put that in the calculator
Yes, sir.
and see how much it gives you. It gives you 1, right?
Yes.
Yes, sir.
So you're going to have 1 divided by, check, I have x times y, and the exponents are what? It's 1 here. And here it's also what? 1, right? So what am I going to do? I'm multiplying here. Let's remember a certain law. I have a law which said whenever I'm multiplying two different bases all to the same exponent, I can keep the bases but give them that same exponent, right?
Yes, sir.
So remember here I had a times b all raised to the exponent of c. So what did I have? I ended up with what? A to the exponent of c multiplied by what? B to the exponent of what? C. Do you guys understand that?
B power C.
Yes. So
Yes,
now what
sir.
are we gonna have here? We are now gonna have it on the denominator. We are gonna have x cubed multiplied by what? By y cubed. So now this is just our final answer because there's nothing more that we can do. Do you guys understand this?
Yes, sir.
So, question. So, like, is it necessary to do the second step, or you could just like move from the question straight into the answer?
Okay. If you are simply able to do that, I highly encourage you to do that, if in case you are that quick. But since this is just an online lesson and I do not know each and every one of you guys individually and your strengths and weaknesses, that's why I was doing a long step. But if in case you can do your mathematics that fast, I highly encourage you. Do not take the long step if in case you can do it fast.
Okay, thank you, sir.
Okay. So let's continue. Let's go back. Let's go back. I'm gonna share screen. Can you guys see my screen?
No, sir.
No, sir. No, sir. Oh, yeah,
Huh?
now we can.
Huh?
Yes, now we
Yes.
can. Yes, now we can see.
You can see or not?
Yes, sir.
Yes.
Okay. So now let me just quickly do like let's say as a small question. Since we are only left with 4 minutes, I'm gonna send another link though. I'm going to send another one. Let me do which question? I'm going to do let's say D. I'm going to do letter D. Right? But if in case we don't finish, we can finish in another link. I'm gonna send another link to the group. So D says D is just simply saying that I have 1 over xy squared. I have 1 over xy squared all to the exponent of -2 multiply by x cubed all over y squared to the exponent of -1. Right? So guys, what is the first thing that we notice? We have negative exponents, right? So we can just swap the numerators and the denominators to make these exponents what? Negative. So let's do that step. So I'm going to, for the first term, what am I going to have? I'm just going to simply have what was on the denominator. I'm going to take it to the top. So I'm going to take xy squared to the top. And this one, I'm going to take it to the bottom. I'm going to have 1 here. And then this exponent now tends to become what? Positive. And I'm now going to keep my multiplication sign. And then I'm going to take this, I'm going to change this -1. So what am I going to have? I'm going to have y squared all divided by what? X cubed. Now this one is now positive. Do we understand each other? Guys?
Yes, sir.
Okay.
Yes, sir.
So
Yes, sir.
this can just be, because I'm dividing xy squared by 1, it's just simply what? Xy squared, right? All to the exponent of what? 2. Do we agree? Because I'm just simply dividing by what? By 1. Huh? Guys, I requested that you mute your mics. Please mute your mics. And then here I'm keeping my multiplication sign, but now I'm raising all of this thing to the exponent of 1. And remember, if in case I raise anything to the exponent of 1, it's just simply that number. So here I'm just going to have y squared all over x cubed without any exponent. So can we just stop here? I'll send another link. Zoom is going to kick you guys out. I'm just going to send another link. Don't worry. So in the mean, you guys can exit. You'll get another link in the group. You guys will get another link. Another link.